Hello everyone, welcome to today's presentation. We're going to be looking at a potential solar plus storage project, residential project at 18 Southwell Avenue in Charleston, South Carolina. So the goal of this project, like we said, we're going to build a residential solar plus storage project. And the homeowners goal is to offset their home electricity use as much as practical. And we'll get into kind of what that practical piece means later on in the presentation. They also want to install a battery system that will provide backup electricity in case of power outages, and it'll also really maximize the use of their solar system. And we'll touch on that a little bit too. And then the customer wants to, or the client wants to use best value products to minimize cost and maximize system efficiency and reliability. So really just, find the best products that will keep costs down, picking products specific for the system design, but that also will maximize the system efficiency and will be reliable for 2 to 3 decades. All right, so to start off the project, we have to look at the home electricity usage. So we got the last 6 months of energy bills from 18 Southwell Avenue. The client gave us their bills from the utility company, so we can kind of see how much electricity the homeowners are using every month. And so looking at the monthly averages, we have 654.5 kilowatt hours per month, and that equates to 7,854 kilowatt hours per year. So in the summer, the electricity use is high due to the AC unit use. So we're in Charleston, South Carolina, and it's going to be really warm down here. So the home is going to have to rely on the grid to make up the energy deficit during the summer months. Looking at July, it's 899, August 992 kilowatt hours per month. And so we're going to try to size a system that's doing about 64.5 kilowatt hours per month. But also in the summer you have longer days, the sun's shining for a longer time, so the solar system will hopefully be able to compensate for that extra energy use in the summer a little bit. But the home's definitely going to rely on the grid during the summer. And then in the winter months, the home will hopefully be able to sell energy back to the utility for a discount on their monthly utility bill. So any extra energy they provide with the net metering laws in South Carolina and the policies with Dominion Energy, who is providing electricity to the home, they will be able to sell back whatever energy they produce in excess of their monthly bill or their monthly usage. All right, so we figured out we need 7,854 kilowatt hours per year of electricity produced by the solar plus storage system to offset the client's electricity usage or yearly electricity usage. So now we're going to look at the site. Can this residential site support that 7,854 kilowatt hours per year? Can we put enough solar panels on the roof to make that amount of electricity is what we're going to look at. So we need to look at things like the roof orientation, which way is it facing, the roof tilt. That's going to affect how much electricity the solar panels can produce, and then also shading. So the big thing with this home, if we look at the picture here, the right side of the roof is completely shaded by some large trees. Actually on the neighbor's property, so we can't cut those trees down. I can't talk about really trimming the trees. So we're really just going to be focused on that left part of the picture there. That's the west side of the roof, so it's facing west, which isn't necessarily ideal. It's not the worst thing, but you would like it to be facing south when you're in the northern hemisphere to maximize the use of the sun. But westward facing will work here. So just looking at the roof space, so we have 450 square feet of unshaded roof space, and that will actually fit 16 solar panels. So these panels are going to be 380 watt panels, so a little bit higher on the wattage range. Sometimes you can see panels as low as 250 watts, and you might use those if you had a ton of roof space to play with. But since we're pretty limited here on roof space, we'll try to get the efficiency up. But they're not the most efficient panels. You have panels that are 400, 450 watts. So this is kind of getting close to that upper tier of for efficiency, but we're trying to get the best value too. So 380 watts is kind of right where we need to be. So that'll give us a total of 6,080 watts. We put it all this data, how many panels we can fit, the roof tilt, the shading, geographic location, um, and we put it into our system, and we come out with 7,515 kilowatt hours per year. So back, we're going for 7,854. So that's actually 96% of the home electricity use, which is, pretty great. So I think, we maximized, the panels. We're going to get the best value panels, and, we could go up on efficiency, but at 96%, I think that pretty much, it's not quite 100%, but it's right on par, and, I think that's a great option for the system. All right, so now we've kind of, the last slide, we just focused on the PV system, and really just the solar panel part of the PV system. We didn't touch on any other components. So now we're going to get into the system configuration, what's going to work best for the client, and with their 16 solar panels. So let's just get right into it. So when you're looking at systems, the main thing you want to look at is where's the inverter going to be placed. So there's a few different options for how to fit the inverter into the system, and there's a host of benefits and or pros and cons, if you will, to the different inverter systems. But for this one, the best is definitely going to be the hybrid inverter system. So this configuration is considered a hybrid because it combines two pieces of equipment into one, and that's the battery inverter and the solar inverter. So when we're looking at a solar plus storage system, a hybrid system makes a lot of sense. Other advantages is that this system uses high voltage batteries that operate between 300 to 500 volts, and those batteries are able to be located on the DC side of the system. This is unlike an AC coupled or an AC battery configuration, which are some of those other types of inverter systems. So this is advantageous for several reasons. So first, it's most efficient to have the battery on the DC side due to much higher charging efficiencies than on the AC side. So can typically be as high as 95%. So secondly, traditional grid-tied solar inverters shut off during power outages for safety purposes, which that would disconnect the solar system during power outages. So for our client here, living in the Charleston area, prone to hurricanes, they're really looking for the battery to provide, that backup power in the case of a power outage. And so, the battery is only going to be able to supply for so long. So if we can continue to charge the battery with the solar panels, the day after the storm goes, we're going to recharge the battery back up. And then at night, you can supply power with the battery. And you're kind of self-reliant, almost off-grid at that point. If, the grid goes down, you're able to continue operating. So that's a huge advantage of the hybrid inverter system. Um, So other advantages, are simple and economical installation and smaller cable size, and also lower losses due to higher voltage of the battery. So this system is really going to be great for the client. It's a newer configuration, but due to all these advantages, it's becoming a lot more common. So we'll be able to find the right inverter, and we'll talk about the best inverter for the system later. To make it economical and also work. It's going to work great for the client. So secondly, a big part of the system is going to be the battery. So we're going with a 10 kilowatt battery here. We already talked about it's going to be high voltage, and then we're looking for that high capacity battery too. What we're going to look for in this battery is 1 day of backup power without the solar, and then we already talked about you'll get those multiple days if the sun's shining and you're able to get electricity from your solar panels. So that 1 day of backup power is going to be just a central load, so it's not going to be air conditioning, but it'll be things like lighting, the refrigerator, some other various loads, TV, that kind of thing, so that the homeowners will be able to stay comfortable in the event of a power outage. And then we just chose one day. Obviously, maybe you could do two batteries and you get 2 days, two 10 kilowatt batteries. But just to keep it economical, go with one battery. That'll give them 1 day of power. Maybe things will be back after a day, but if not, if the sun's shining the next day, they'll be able to keep going, charge the battery back up, get electricity to the home, um, and try to, live as normally as possible. All right, so the main components, we've already talked about some of them, but we'll go into a little bit more specifics here. So the solar panels, we're going with a REC 380 panel. So this is high efficiency at great value. We've already hit on that. It's going to be 7,500, and that's for the all 16 panels. So that's about $1 a watt. So that's kind of in the lower range for panels, especially high efficiency panels. So that's a great price there. So charge controller, that's something we didn't touch on, but for our inverter, the charge controller will actually be a part of the inverter, and that's going to control current going into and out of the battery. So super important, but like I said, it's contained within the inverter, which is great because that's two components for the price of one. And then the battery bank, so we're going with the LG battery, high voltage, high capacity, economical. We talked about the advantages of the battery we chose, and it has to be high voltage for that hybrid inverter. So the battery bank is actually going to be $10,000, so pretty standard for a 10 kilowatt battery. 10,000 is it's a good price. It's a great battery too, very reliable. LG is a great brand. And then lastly for the inverter, so perfect size inverter, and then also great value. It's gonna be $3,500 for that. And so yeah, super important to keep the battery and inverter, on the lower side of the price range, because we'll talk about a little bit later on. Those are components that are going to need to get replaced, at least once, maybe twice during the life of the whole system. So component location, so solar panels are going to be on the roof, obviously, that I've talked about. And then the battery and inverter will be placed on the east side of the home, next to the driveway, as shown in the pictures here. So that's right next to the power meter, easy hookup to the grid, and then easy access for maintenance. And then also, it'll be next to the house. A lot of times you have inverters, maybe inside of a garage space or something like that. That doesn't really exist on this home. It's a very small home. There's not a lot of inside space for inverter. So we'll try to keep it close to the home, keep it as weather protected as possible. All right, so I think we've hit on all the major components in the system. So now I think it's kind of more time to shift focus to operations and maintenance of the system. So first things first, commissioning. So commissioning isn't always used for residential PV and storage systems, but we are definitely going to recommend bringing in a third party to commission the system. And the reason a third party is important is, they're independent. So get that independent backup. They can come in, test the system, make sure it meets their standards, and we fully expect it to meet our standards and their standards as well. And this will be a great way to make sure everything's working properly. So they'll verify mechanical systems, verify system response, power outage. So that's important to the client. And then they'll actually come back a year later and do all those pretty much those same checks again. Make sure there's no serious degradations in the system and everything's functioning properly. So performance indicators. These are things that the homeowner is going to be responsible for looking at on a monthly basis or more frequently, up to the homeowner, but we recommend at least monthly. And this is just to make sure that the system's operating properly. And if there's any issues, the homeowner can look at the data, understand the issues, and then communicate it to the installer. Obviously, the homeowner is expected to be an expert on the system, but we'll give them a little bit of training, tell them what to look at, and then that way they can get back to the installer, and we'll come take a more detailed look at the system, any issues that come up or questions that might arise. So I'm not going to read off this list of data to be monitored. I will hit on some of the big ones. So peak power delivery, real power and energy delivery, estimate of the power that should have been produced, So these are all really important things. Measurement of soiling that could go, that is going to be related to those parameters we just talked about. So really, you're just making sure the system is operating at full capacity, and there's no temperature concerns or soiling concerns that need to be addressed. So safety concerning parameters, those will automatically be monitored by the installer, and then other than that, if the client notices any decrease in energy production, that's definitely something that needs to be communicated to the installer as soon as possible. All right, so maintenance. So the big thing when you think about PV system maintenance is system cleaning. So really just spraying off the panels. So actually, rainstorms are typically enough to keep the panels clean throughout the year. But if you ever do, this time of year, pollen levels are really high. So if there's a dry week, you might want to jump up on the roof and spray those off. If you're not comfortable doing that, I wouldn't really worry about it. You'll be able to monitor the data to see, how the soiling is kind of affecting things. If it becomes a huge concern, definitely give the installer a call. But or jump on the roof and spray it off if that's something you're willing to do. But hopefully that won't usually be required. Other big things is battery and inverter replacement. So we kind of already touched on a little bit. The life of those two components is about 10 years. So the life of the PV system will be about 25 to 30 years, or sorry, the solar panels will be about 25 to 30 years. So you're looking at 2 to 3 battery and inverter replacements throughout the life of the system. So those are going to be pretty, we talked 10,000 for the battery, 3,500 for the inverter. So just making sure you're planning on those and understanding those maintenance requirements. Otherwise, if something breaks, something happens like that, definitely the installer will be, able to fix those issues that come up. So, so who can perform maintenance? So that'll be the installer. So they have an in-house operation and maintenance service, and this will make sure you get uniform quality maintenance across the whole PV system lifecycle. So you definitely there's third-party maintenance organizations out there that'll come work on your panels. So one, make sure those third parties are qualified. So licensed electrical contractor if they're doing electrical work, the NAB CEP certification for any type of PV system work, something you definitely want to look for. And then if they are an electrical contractor, make sure they're trained in medium voltage DC electrical systems. So rather than having to do all that, I would definitely recommend just working with the installer, working with our maintenance teams that are qualified and know what they're working with. Make sure you get quality work and everything's taken care of. So how is this, this whole maintenance plan going to be communicated? So the initial contract will be an agreement between the homeowner and the installer. And then also we talked about that third party commissioning partner. You also have an agreement in there with them. We talked about, corrective maintenance issues that come up, or, you're monitoring your data and you said that something doesn't look right. Will be the homeowner's responsibility to contact the installer to make sure, everything's working appropriately, have the installer come out and check things out. Yeah, that's pretty much it for operations and maintenance. That's it for the system. We're definitely really excited about this project, and I hope you are as well. I appreciate you taking the time to listen to the presentation today. Thank you.